quad this is week 70 of the Perl Weekly Challenge. Alright, I'm going to get right into this. You're given a string S of size n. So the example is n is the count S, which is Perl and Raku. And you're given a swap count C and an offset O such that C is greater than or equal to 1, as is O. And you're given a swap count C and an offset O such that C is less than or equal to O, and they're both greater than or equal to 1. And also C plus O is less than or equal to n. So I'm just going to go by the example here. Write a script to perform character swapping like below. I'm thinking the C mod n gets swapped with 1 plus O up to C plus O. So I think we can do all of these swaps in a single operation. And looking at the example, swap 1 is in this position, this position, so I'll want to chain swapping. Okay, and we'll use our sample string, Perl and Raku, and 3, 4 for C and O. And we'll sort that out in a second. So alpha is our string, C, O gets omega. Our count n is the length of our string alpha. And now we basically just code in the rules. So our string indices are 1 up to C. Oh, quad A was supposed to be 0, so let's do that. Ride won't let me edit twice at the moment. Okay, there we go. Yeah, Ride is sometimes annoying when you want to work in this way. I can just write it all out, it should work. So our string indices are I to C, 1 plus, and mod n. Okay, so that's what's written here. Basically 1 up to C, mod n, modded by 1 plus I to C. And our replacement indices are 1 plus O up to C plus O. 1 plus O is 5, C plus O 7. So, and n mod as well. N mod 1 plus O plus O to C. Alright. N mod 1 plus O plus O to C. And then it's literally a matter of taking our string at our replacement indices at string indices. Oh, we haven't actually made those yet. We can do that though. Okay. Right, Pundandraku. So that's one of the swaps, and then we just need to do another swap, I think, which is the string, because it's a swap, the string at the string indices at the replacement indices. So that's S, character swapping 3, 4, where S is Perl and Raku. Okay, grey code sequence. You're giving an integer grey code sequence from the 2-bit grey code sequence. You follow this step, and I'm guessing we can have 2-bit. We can have 2-bit hard coded in, and then just build up to the 5th one from there as needed. So, the most efficient implementation, if you're only allowing those many, is to just store all the sequences. That'll be we can look at that at the end for interest. So, I wonder if we can do this as a deepen. We start with the 2 bits, 0, 1, 3, 2. Start from there, and we want to generate 3-bit from there, but we probably won't need that for the first step. Is binary form, so 2 base power negative 1 of alpha converts that to this binary. Each column is the there's the reverse of that. Prefix all entries with a 0. Since it's this sort of column-wise representation, that's how we want to do it. Comma bar there. Prefix S1 with 0s, S2 with 1s, and concatenate S1 and S2 together. And there's some kind of train, and we're concatenating S1 and S2 together, right? Literally like that, or possibly comma bar, let's see. Where S1, let's call that right tack for now. S1 is, oh, we don't want to reverse yet. Prefix all entries of S1 with 0s, and S2 is the reverse, also and prefix with 1s. Yeah, what have I done? Is it this? Okay, let's do them one at a time. Not you. Really, that's in the top. Okay. So that's reversed and prefixed with 1s. And then it's just prefix the binary form with 0s. That's on the top of a 3 train. Oh, we need to concatenate between. No. Oh. What? What's the length error? Concatenating 0s. Yeah. Dum. Like this. And that's S1 concatenated with S2. 000, 001, 011, 010, 110, blah blah blah. And then just 2 base, stick it all back. Yep. And if you want to do the 4th, you take this whole thing. Oh yeah, can we simplify this train? That's the 3. And that. Now that has to go together, I think. Unless. Huh. Yeah, that's neat. 2 base power neg 1 right tack, that's a 3. Yeah, but you want it's an under, and we don't omega. I'm just saying that if we put 4 in, we do its power omega minus 1 times. Where's that? Then that's the 4th one. So we put in 3, that's the 3rd. 3 bit, oh, that's not. Oh, silly. Minus 2. Yep. So 2 is a no-op, and we get just the original sequence. So let's bring this up to the top so it's easier to see. So using the power operator, we're saying do this whole function, do the n+1 grey code sequence to the power of omega minus 2. So that's saying do it omega minus 2 times. So if here omega is 2, 2 minus 2 is 0, it becomes a no-op, and we just get the original alpha 2-bit grey code sequence. If we give it 3, then that's 3 minus 1, do it once, we get the 3-bit grey code sequence, 0, 1, 3, 2, 6, 7, 5, 4. Do it 4 times, it'll do it twice, and we get this one, 0, 1, 3, 2, 6, 7, 5, 4, 12, etc. And we can go all the way up to 5, which is 32 numbers long. And I'd be interested to see how far we can go before it craps out. Oh, okay, so the powers of 2 in length. Makes sense. Do the 15-bit. 20. Wistful at 30. Wow. 23. 24. Good times. Okay, so yeah, they just get really long, these sequences, I suppose. That was it. Really cool this week. That I don't think I'm even. Oh, I haven't actually named that one. No, it's all one line. So we'll call it Grey Code Sequence. Earlier on, I think I mentioned doing a more efficient implementation of a grey code sequence, which is basically just storing them in a variable and indexing into it. So if we have a grey code sequence is grey code sequence each of 2 plus OEN print. No, okay. Grey code sequence each 1 plus iota 2, 3, 4, 5. That's the 4 there. 2, 3, 4, 5 is 4 numbers, right? And we can ask if grey code sequence number 3 matches, which it should do, grey code sequence 3. Oh, because they're nested for some reason, despite me having oh, sorry. Ha 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 ha. Okay. Anyway, okay, so there we are. So if we make a new one called GCS Quick, which is just omega minus 1 GCS picked by alpha picked by and GCS attached to that. Cool. So now runtime compare GCS Quick 4 with grey code sequence 4, which would be the we're allowed up to 5 actually, but that would have been unreasonably unfair. Yep. So look at that. Orders of magnitude quicker if you just store it in a variable. Anywho. Alright. Yeah, not loads to say this week, except I'm very happy because this didn't take me very long, because in both cases the APL solution is basically just a translation of the algorithm description pretty directly. I mean, I guess that's true of any language, but look at that. I'm particularly pleased with doing all the swaps in one crack. So that was week 70, Perl Weekly Challenge in Dialog APL. Thanks again very much for watching. See you next time.